play a game! How about a game to test your reaction skills? Choose the LED that you would like to land on, test yourself or against another player to see if you can stop the light on the selected LED. The bottom button starts the game by cycling through 10 LEDs. The top button stops the cycle on a certain LED. This circuit is comprised of two 555 timers and a decade counter. The first 555 timer is in bistable mode. There is no timing element in this part of the circuit. It alternates between two stable states, high and low. Pressing the start button, the trigger pin will receive power, and this allows the current to flow from VCC to ground and output goes to high. Pressing the stop button, the threshold pin will receive power. This creates a path to bypass the start button and the output goes low. The pull-up and pull-down resistors are in the circuit to ensure that the trigger and threshold pins are either high or low and not floating. The second 555 timer is in astable mode. This is sometimes referred to as free mode, meaning it is continuously oscillating. The RC circuit controls the frequency of the oscillations. The impedance and frequency are inversely proportional, therefore the period is directly proportional to the impedance. This means that as the impedance decreases, the difficulty will increase by speeding up the LED cycle. The decade counter is comprised of 16 pins. 10 of those are output pins, connecting to the LEDs. The clock pin receives the oscillations from the astable timer when the bistable timer is high and oscillates until the bistable is turned low. The decade counter advances its count at every rising clock edge. It is important to note that in order to implement the switches, there must be two 555 timers. This is because the bistable timer, when logic high, the astable timer will oscillate and therefore change the decade counter based on the output of the RC circuit. When the bistable timer goes logic low, it resets the astable timer, holding only one LED on. It doesn't turn off the LED because there is still power connected to the decade counter. Now let's talk about the RC timing circuit in the astable mode. The values we chose, 750 ohms and 10 microfarads, sets the period to 0.16 seconds, which means that every 0.16 seconds, the lit LEDs will change and go to the next output on the decade counter. This was chosen since the average human reaction time is 0.25 seconds, which presents an above-average challenge for the players. This game was created out of basic hardware components. There was no software implementations involved. By using only 3 ICs and fundamental circuit knowledge, a fun party game was created. Thank you for watching and happy playing!